This is Algebra 2, Lesson 8-6, Solving Rational Equations. A rational equation is an equation that contains at least one rational expression, and it has to have an equal sign. To solve an equation containing rational expressions, the whole concept is to get rid of the denominator. So you do that by multiplying each side of the equation by the least common denominator. Okay? But unfortunately, doing that can also introduce what we call extraneous solutions. Okay? Because when you multiply both sides of an equation by the same algebraic expression, an extraneous solution can be a solution of the derived equation, but not a solution of the original equation. Because of that, you must check all your solutions of the derived equation in the original equation to see if any of them may not be solutions to the original. So in other words, check everything. That's why it's in red. We're going to solve some rational equations here. What are the solutions of the rational equation? 5 divided by 2x minus 2 equals 15 divided by x squared minus 1. Now I can find the least common denominator of both of these denominators, or I could look at this and say, hey, this is one fraction equaling another fraction, which makes it a proportion. Proportions are easier to solve by cross-multiplying, so that's what I'm going to do. Because if I cross-multiply this particular equation here, I won't have a denominator anymore. So I'm simply going to just cross-multiply. I'm going to put down 15 times 2x minus 2 equals 5 times x squared minus 1. So all I'm doing is multiplying my cross products. Now I'll simplify by multiplying that through. So I get 30x minus 30 equals 5x squared minus 5. Since this is a quadratic, because it's to the power of 2, I need to put everything on one side of the equation and then factor it to solve it. So I'm just going to move everything from the left side to the right side. So I'm going to subtract my 30x, and I'm going to add my 30, subtract my 30x, add my 30, and I'm going to end up with 0 equals 5x squared, keeping this in standard form, minus 30x plus 25. So now I have this, and I'm just going to move it to 5x squared minus 30x plus 25 equals 0. So I'm going to factor this out. I'm going to take a 5 out, and I get x squared minus 6x plus 5 equals 0. So that will factor to x minus 5 times x minus 1. So I'm going to 5 on the next side. To solve this, set each part equal to 0. Since 5 doesn't equal 0, I can ignore that part. So I have x minus 5 equals 0 and x minus 4 equals 0. So therefore, x can equal 5 or x can equal 1. So now I have to check these because we always have to check them back into the original equation. Okay, so here's my original equation up here, which I've made a mess out of, so I'm going to put it down here at the bottom. And I'm just going to write it in red so that I can see it a little bit easier. I have 5 over 2x minus 2 equals 15 over x squared minus 1. And I'm going to check each one of these problems to see if they make a solution. So the first number I'm going to check is 5. Check 5. So 5 over 2 times 5 minus 2, does that equal 15 over 5 squared minus 1? So this would be 5 over 10 minus 2, which is 8. Does that equal 15 over 24? Because 25 minus 1 is 24. Well, I know 15 over 24 reduces to 5 out of 8, so we know that 5 is a solution. So that works. So now I have to check the solution of 1. Okay, so now I'm going to check 1 in here. That gives me 5 over 2 times 1 minus 2 equals 15 over 1 squared minus 1. Right? I now have 5 over 0. Does that equal 15 over 0? 0 is undefined. You can't divide by 0. Dividing by 0 is undefined, therefore 1 is not going to work, so my only solution for this equation is 5. So that's if they end up to be a proportion, that's the easiest way to solve it. If we look at letter B here, letter B is not going to be a proportion, but I can look at this and go, my common denominator is going to be 3 times x times 5, so basically it's 15x. Okay, my least common denominator is 15x. So I'm going to take each part of this fraction and I'll multiply it by 15x. And I rewrite it so that I can see it nice and neat. Everything has to be multiplied by the least common denominator. All parts of the equation. Because now I look at it and I say, what can I cancel out? 5x goes into 15x 3 times. 3x goes into 15x 5 times. 3 goes into 15 5 times. Now I canceled everything out. Now I simply just multiply. 3 times 3 is 9. 4 times 5 is 20. And that equals 1 times 5x is 5x. Notice there's no more denominator. They all canceled out. That's the whole point. If they don't, you don't have the right least common denominator. So now I have 9 minus 20 equals 5x, so negative 11 equals 5x. Divided by 5. X equals negative 11 fifths. Now we must check it. And we must check to see if 11 fifths fits in this equation. And I'm just going to rewrite the problem down here so I can actually see it. So I have 3 over 5x minus 4 over 3x equals 1/3. So we were looking at this one. Yuck, I have complex fractions. Yeah, you can do it. We'll show you. Good practice. So I'm going to have 3 divided by 5 over 1 times negative 11 over 5 minus 4 divided by 3 over 1 times negative 11 over 5. Does that equal 1/3? You could stick this on your calculator if you wanted to, but let's just say you forgot the calculator, and you actually have to do math using your brain calculator. These will cancel out. I get negative 3 over 11 minus 4 over negative 30 fifths. Does that equal 1/3? You're like, oh, complex fractions, I hate them. Negative 3 over 11 minus 4 over 1 times 5 over negative 33. Does that equal 1/3? Okay. So, going by a little bit further, negative 3 over 11 is then going to end up to be plus because I've got a negative here and a negative there. So plus 20 over 33, does that equal 1/3? Negative 3 over 11 to get common denominator of 33. You can multiply the bottom by 3, so that equals negative 9 over 33 plus 20 over 33, which equals 11 over 33, which equals 1/3. It checks. So the check was harder than the problem itself. Okay, so our problem is, don't be lazy and not check and just do it assume it's going to work, because those will be the problems that you'll mess up on. Okay, so rational equations. Now, with rational equations, we can have word problems. Okay, so using a rational equation, the aerodynamic covering on a bicycle increases the cyclist's average speed by 10 miles per hour. The time for a 75-mile trip is reduced by 2 hours. What is the average speed for the trip using the aerodynamic covering? Okay, this is a distance rate time problem. So I'm going to say without the covering and with the covering. Yeah, distance rate time. Making these little tables does help organize your thoughts and does help organize your answer. Okay. The aerodynamic covering on a bicycle increases the average cyclist's speed by 10 miles per hour. The time for a 75-mile trip is reduced by 2 hours, which means the distance for both trips is 75 miles. Okay? Without the cover, we're saying the time is t. With the cover, the time is going to be 2 hours less. Okay, so that part's easy. Everybody's like, where does this 10 come in? I'll show you where the 10 comes in. Okay? You know that distance equals rate times time. So if distance equals rate times time, rate equals distance divided by time. Okay, so distance divided by time. Distance divided by time. Okay. So now let's relate this. The speed with the cover is equal to the speed without the cover plus 10, right? Because that's where the 10 miles an hour comes in. Okay? Because it increases, because we're talking about speed. So the speed with the cover is 10 miles an hour faster than the speed without the cover. As it says, an aerodynamic covering increases the cyclist's speed by 10 miles an hour. So if he was going 30 without the cover, with the cover he can go 40. So the speed with the cover is 75 divided by t minus 2. That's going to equal the speed without the cover, 75 over t, plus 10. We now have our equation. And I should have defined it too this time. I always define the variables. So now we just need to solve this equation. So I'm just going to move it over here so that I can work with it a little bit better. So I have 75 over t minus 2. And my common denominator, if you haven't figured it out, is t times t minus 2. So I'm multiplying by t times t minus 2 equals 75 over t times t minus 2 plus 10 times t times t minus 2. Okay, so there's my equation. I've taken care of the common denominator is t times t minus 2. This cancels with this, and this cancels with this, and nothing cancels over there. So now I've gotten rid of my denominator, so I have 75t equals 75 times t minus 2, and that plus, plus 10 times t squared plus 2t, and minus 2t. All I did was multiply by 2. Okay. All I did was t squared minus 2t and then multiply that by 10. So there's my generic equation. Okay. So I have 75t equals 75t minus 150 plus 10t squared minus 20t. Now we can simplify this. Get everything set equal to 0. All right, so I'm going to move this 75t over here. And I now have 0 equals 10t squared, because I'm putting it in standard form, minus 20t minus 150. Okay. So I need to factor that. I'm going to move this over here so I can actually factor it. If I take a 10 out of that, I'm going to be left with t squared minus 2t minus 15. So I need two numbers to multiply together to get 15, add together to get negative 2. That's going to be negative 5 and positive 3. So t minus 5, t plus 3. Okay, so t can equal 5 over negative 3. Well, the last time I checked, we can't have a negative time. So it's going to increase, time's going to equal 5. Okay. I'm going to leave no space for this. I'm just going to open the blanks screen for a minute. So we now have the equation down to this. We have it down to 10 parentheses t squared minus 20t minus 1. 50. Oops. I'm just going to back up. Sorry. We have 10 parentheses t squared minus 2t minus 15, which we factored to t minus 5 times t plus 2, which we solved to t equals 5 or t equals, not 2, 3. I'm having a hard time today. T plus 3. I can't have a negative amount of time, so we know this comes out of the equation. So t equals 5, but that's not the answer to the question. The answer to the question isn't how long would it take. The answer to the question, what is the average speed of the tip using the aerodynamic coverage? So, t equals 5 without the cover, because if we go back to our chart over here, go back to your chart, t is the time without the cover. So we need to know what the speed with the cover. So we need r with the cover. We go back to our table. R with the cover is 75 parentheses t minus 2. So that's going to be 75, 5 minus 2, so 75 divided by 3. 75 divided by 3 is 25 miles per hour. So the speed of the bike with the cover is 25 miles per hour. All right, a couple of other problems. Go back to here. Jim and Alberto have to paint 6,000 square feet of hallway in an office building. Alberto works twice as fast as Jim. Working together, they can complete the job in 15 hours. How long would it take each of them working alone? So, if it takes them working together 15 hours, each of them alone is going to take more than 15 hours. So when you get your solution, make sure that each person is more than 15 hours. If they're not, you know you're wrong. Now, there are two ways to set this up. The book sets it up kind of weird. I have a specific way I really like to set these problems up. I'll show you both ways and let you choose which way you like better. Okay. So I'm going to let x equal Alberto's rate. Okay. So x is going to equal Alberto. I'll make it his rate. And it says Alberto works twice as fast as Jim. So if Alberto takes 5 minutes or 5 hours to do something, Jim would take twice as long as that, or 10. So that means 2x, is going to be Jim's rate. Okay? Because he takes twice as long. Well, not Jim's rate, Jim's time, basically. Okay. So Alberto's time is x and Jim's time is 2x. Okay. So I know that Alberto's rate plus Jim's rate has to equal the combined rate. Okay. So plus Jim. Not Jim. Equals combined. Okay. Now this is the way I set it up, not the way the book sets it up. And I'll show you how the book sets it up in just a minute. Okay. If Alberto can do things in X amount of time and Jim can do things in 2X amount of time, okay, in 1 hour, okay, they can each do a specific part. Part in 1 hour. Okay. In 1 hour, Alberto can do 1 over X of the job. And Jim can do 1 over 2X of the job. Okay, it kind of makes sense to me. Alberto can do 1 over X, and Jim can do 1 over 2X. Okay. The original problem talked about them together in 15 hours. So in 15 hours, Alberto's going to do 15 over X, and Jim's going to do 15 over 2X. Okay. The 6,000 square feet that they have to paint, 6,000 square feet, is the one job they need to do, one completed job. Okay. I don't like to add the 6,000 in because it makes my problem really, really big. The book likes to, I don't. I was taught this way by a college math professor, which I really liked, because it does work and it's a lot simpler. So we just made every job, whatever it was, painting 54 books, shoveling 500 sidewalks, whatever, we made that equal to the job that they needed to get done. So if they can do it together in 15 hours, we know that the part that Jim can do, okay, the part that Alberto can do, plus the part that Jim can do, has got to equal the entire job done, because they have to do it together. Together they did it in 15 hours. So the part that Alberto did in the 15 hours plus the part that Jim did in the 15 hours got the job done. So that's my rational equation. Okay. So now to solve this rational equation, I just need to multiply by the common denominator, which happens to be 2x. So we'll multiply everything by 2x. So I will end up with this x cancels with this x, that's 30, plus this 2x cancels that 2x plus 15 equals 2x. So we get 45 equals 2x, divided by 2. X equals 22.5 hours. Okay, which makes sense because that's more than 15 hours, and x happened to be Alberto's time. Okay? So it takes Alberto 22.5 hours. So if Jim is 2x, okay, so 2x is going to equal 45 hours, isn't it? So working alone, it will take Jim 22.5 hours and Alberto 45 hours. Okay? Okay, we have that problem written in a complete sentence because it's a word problem. Now, I'm going to show you how the book does it, which I personally think is a little harder because the numbers are a lot bigger. It's the same basic concept. Okay? Same basic concept. You still have Jim, you still have Alberto, but now you got to deal with that 6,000. What they'll do is what the book says is, oh, since Alberto's time is x and Jim's time is 2x, Alberto's rate is going to be 6,000 over x, plus Jim's rate is going to be 6,000 over 2x, and that's going to equal the part they can do with 6,000 over the 15 hours. That's how the book sets it up. It puts that 6,000 in it. But if you'll notice, okay, I basically have the same thing with my 15 over 15 and 15. If I replace my 6,000 with 15, I have 15 over x plus 15 over 2x equals 15 over 15. Okay? So the problem sets up the same. This way has just huge numbers I've got to deal with. I'll show you what I mean. My common denominator here is 30x. I'm going to multiply everything by 30x. Okay. So the x's cancel out here. 30 times 6,000 is 180,000. Okay. Let's just take it out there. Here, this goes to 15 times. 15 times 6,000 is half of 180,000, so it's 90,000. Equals 15 goes to 30 twice, so I have 2x times 6,000, which is 12,000x. So I have these giant numbers I'm dealing with. So I have 270,000 equals 12,000x. Okay. So if I divide by 12,000, okay, I get x is 22.5. So I get the same answer, but to me the numbers are much larger and it's a lot easier to mess up something. I don't like that problem, the way that sets up. I like, figure out how much they can do in 1 hour, figure out how much they can do in the combined number of hours, make it equal to one job, and just get it done. All right, the last problem. A boat travels, this is a time problem. A boat travels 246 miles downstream in the same time it takes to travel 180 miles upstream. The speed of the current in the stream is 5.5 miles per hour. Find the speed of the boat in still water. Okay, so we have it traveling downstream and upstream. So downstream, upstream, this is a distance rate time problem. Distance rate time. We're supposed to find the speed of the boat in still water. So I'm going to let R equal speed in still water. Okay. It can travel 246 miles downstream. That's the distance downstream. In the same amount of time, it takes to travel 180 miles upstream. Still T. Okay. Remembering that you have the current here. Downstream, the current is pushing us, so the rate of the boat going downstream is going to be the rate of the boat plus 5.5. Okay? The rate of the boat in still water plus that 5.5, it's pushing and helping it go downstream. Upstream is going to be the rate of the boat minus that 5.5 because it's pushing it back. We're supposed to find speed. Now remember, before we could have solved this by setting this equal to 2 equations and solving the 2 equations simultaneously. We're going to set this up as 1 equation and solve it with 1 equation because we're going to set it up as a rational equation. Remembering that we're supposed to find speed, okay? And we know that distance equals rate times time. Since the times are equal, time up equals time down, I can set my times equal, so I'm going to take this distance rate time equation and set it equal to time. Time is equal to distance divided by rate. So since my time up is equal to my time down, my distance, 246, divided by my rate, R plus 5.5, that's up, that's downstream, is equal to my time upstream, 180, over R minus 5.5. So there's my equation. Nice little rational equation, which also happens to be a proportion. So now I can just cross multiply. So I'm going to have 246 times r minus 5.5 equals 180 times r plus 5.5. If I distribute 246r minus 990 equals 180r plus, no, wait, I'm going to say that, and then I can multiply there. 246r, 246r minus 1,353 equals 180r plus 990. Buttons in the calculator. Okay, so get everything equal to itself, so I'm going to add 1353 here. I'm going to subtract 180r here. Those cancel. 246 minus 180 is 66. And 1353 plus 990 is 2,343. Now all you need to do is divide by 66. R will equal 35.5. And that's R, it happens to be the speed of the boat in still water, and that's what I was supposed to find. So the boat is traveling. Boat speed in still water is 35.5 times 30. And there you have solving rational equations. I actually think rational equations are fairly simple. If you can set up the rational equation, solving it is actually the easy part. Setting it up is the complicated part, but they're fairly simple to set up once you get used to the process of it.